Welcome to an ECE, Electrical and Computer Engineering Technical Elective, and AMP, Accelerated Master's Program information session. This is designed to help you select your technical electives in the fall of 2020, and it's also going to tell you a little bit about the AMP in terms of, if I can remember the questions that the students have asked, is the AMP a good fit? And when do you start considering the AMP? But before we get into the AMP, which we will sort of finish up with, let's get started with talking about technical electives in the Electrical and Computer Engineering program. And to get you oriented or thinking about where do you need to look or what should you look for, you might start trying to interpret the code that has been established or attempted in labeling or numbering our courses. Here it's laid out in a linear fashion, but you can see that the 20s, 30s, and 40s corresponding to classes that really sort of transition you into these technical electives from having already taken 220, 320A, 340A. These are signals and systems classes, or classes that are in the controls, communications, and signal processing areas. So if you were comfortable with your 320, your 340, or even if you weren't comfortable but you think you want to follow up on those classes or classes that have those as fundamental or foundational material, then you might be looking at the classes that end in 2s or 20s, 30s, and 40s, be those 400 level, 500 level. You can take 500 level classes as an undergraduate student as long as your GPA is sufficient. In the 50s, that's following up on the electronics classes. And so that's 351C and 352 would be your prerequisite courses there. In the computer area, we've designated these 2 decades, 60s and 70s. If you've liked programming, then you might want to look at the 70s or the courses that have numbers that involve the 60s and 70s. And then if you're interested in electromagnetics following up on 381, then you might be looking at the 80s. My suggestion as an undergraduate student in electrical and computer engineering, you might think about not focusing on any one of these 4 general areas, but maybe dividing your courses that you're selecting for your technical electives among these different categories so that you have some breadth. It's probably going to be easier to learn this material now versus trying to get yourself up to speed in an area that, oh, I could have taken that class as an undergraduate and I didn't. Well, now's the time to be considering what is it that you think you would like to have as a foundation so that when you continue along in your career, which is going to be 20, 30 years from now, that's going to involve quite a bit of technological development from today. And what do you think you might need in terms of foundational material to keep you up to speed and up to date on the new technologies as they arise? Let's now start with the classes that are planned to be offered in the fall of 2020. And maybe before we even get into the fall 2020, one of the questions that students asked was, what technical electives are there going to be in the summer? And right now, in terms of classes that are being planned for the summer, that's now 441A, which is a controls class, and 535A, which is a communications class. And you would need to have had 340A to take 535A, and you will have had to have 320A and an appropriate GPA to get into those. And those classes will be taught in an online format in a 10-week session, so it will span both 5-week sessions in the summer, and that's what's now being planned for the summer of 2020 for technical electives. That then gets us into the fall, and I've tried to categorize these or organize these technical electives consistent with these different areas: computer, electromagnetics, electronics, signals and systems. And you'll notice that I have actually included some 300 level, but those are only available for the students that are not required to take those classes towards their degree if they are in the computer engineering option. So 369A, how do you build a computer from scratch, computer architecture, that's now available for electrical engineering option students. Electrical engineering option students also can select to take a core class that's a core class in the computer engineering option, and that's object-oriented software design. How do you structure these programs that are starting to grow and grow in size? And if you wanted to extend your understanding beyond 275, 375 or 373 then is a logical extension. If you've always wanted to know, how do I now put these systems or model these systems, 411, 511, I'm listing the dual numbered classes. If you're going to pursue an AMP, you could think about taking the graduate level class in these dual numbered classes to satisfy or to actually be one of your technical electives that you take towards your AMP degree. And the AMP allows you to basically count the same class, let's say 511, towards your BS degree and your MS degree, as long as you are in good standing and follow through with the process. But 411, 511 talks about how do you model these physics and biological systems. And if you want to know a little bit more about those, I'm hoping that you can now go to my website and actually find, this is now just a one-page document. Obviously it's dated fall of 2019, but that's now not that dated in terms of what you might want to find out. Here is the course description. It talks about how it might be co-convened with another class and what are maybe some prerequisite classes that you need to take. And here you can see then that they're going to be talking about some fundamental systems associated with physics and biology, be that harmonic and coupled oscillators, electric fields with respect to electric lenses, etc. And so here you can, in numerical order, search for the classes that we are now saying will be offered during the fall of 2020. The follow-on class below that in this list is then 413, 513, which is Web Development and Internet of Things. How are these smart devices connected through the internet, or how do you use the internet to talk to these devices? That might be something that you're interested in. Then that's 413 or 513. 474A, I'm just going to say the 400 level version. Computer-aided logic design. If you liked 274A, this is sort of the next step in that progression. Obviously, you're going to be getting it at a much higher level than what you had in 274A, but in terms of performing logical operations in a computer, that's what you're now learning in 475A. 478, if you now have a network of computers, how are they interconnected? How do they talk to each other? How do you make that happen? That's 478. If you're interested in cybersecurity, you might want to think about 478, connecting it up computers. You might actually be interested in this Internet of Things class, and then you can take like a 509. This one's not dual numbered, so you would need to be at an appropriate academic level to take 509, but I believe that's now having a GPA better than 3.0 to register for ECE 509, which is dealing with the concepts, theory, and practice of cybersecurity. One more class in the computer area, although these classes start to jump boundaries many different times in terms of you might see that 411, 511 in a signals and systems classification. So don't think that, oh, I'm not in the computer engineering option, I can't take that. Well, no, you probably can. Likewise with 576A, that's engineering of computer-based systems. This gets into some artificial intelligence, some simulation modeling, knowledge-based systems, and now if those are distributed, you have software, hardware, communications issues. How does all of that get organized into an engineered system? That's 576A. I'm not sure if that will be, actually, yes, we're in the fall of 2020 or planning, so that one is, these are fairly certain to happen in fall of 2020. If you're interested in electronics and bio type classes, then in the fall you have electrical and optical properties of materials, that's 434. If you wanted to know how do you build these or manufacture these semiconductor devices, that's 446. What about analog integrated circuits, a little bit beyond what you learned in 351C? Now you want to know, okay, how do I put all of these? Now in 351C, a lot of times you were interested in a single transistor. How do you package many, many, many different transistors into an integrated circuit? That's this 450, 550. And another one that I've lumped here, which could have been lumped maybe in the computer area, is design, modeling, and simulation for high technology systems in medicine. That class requires at the 400 level that you be an honors student, but if you are, you can take that to satisfy one of your technical elective requirements. In the electromagnetics area, there's 581A. If you liked 381A, this is a logical extension of that. This obviously, though, is a graduate level class. It's not dual numbered, so you're now jumping in with all graduate students, but you will now learn electromagnetic field theory at a deeper level than what you had in 381A. Microwave engineered systems or microwave engineering. These are the passive circuits. How do you design those circuits at the microwave frequency area? And then another class in electromagnetics and optics is the holography and diffraction optics. How do you build a hologram, and can you use it? What are some of the applications of that? That's 527. To round out those different areas, now I'm looking at the signals and systems courses that are offered in the fall of 2020. You have digital signal processing. If you wanted to know how do you do some of this filtering in a digital sense, that's now digital signal processing. How do you do optical communication systems? That's 430. Now I'm looking at some pure graduate level classes. Digital image analysis, that's 532. And what does that look for? That's now looking at maybe finding features in an image. You might be looking at boundaries or segmentation or maybe something flowing. Can you make that determination in digital image analysis? Digital Communication Systems 2, that's a follow-on to 435A, 535A, so if you haven't taken that, you don't want to jump into 537. But if you've now completed 435A, then you could take 537, which is the next step in digital communications. If you're interested in radar signal processing, how do we create a radar system? How do you do signal processing with radar? What's synthetic aperture radar? Those are topics that are covered in 538. Automatic control systems, that's your first introduction to designing controllers. How do you change the dynamic behavior of a system? How do you make it perform better in terms of how you want it to perform? And a couple of graduate only or graduate level classes are 501B, Advanced Linear Systems Theory. That's linear algebra. More generally, it's a theorem and proof type class, but it's designed to take you or to make you feel a little bit more comfortable transitioning from the finite dimensional domain into an infinite dimensional domain. And finally, probability and random processes. This obviously is a much more advanced course than what you have taken as ECE 310, but this now is a foundational class that you will see needed or useful in many subsequent graduate classes. If you are trying to now plan your selection of classes, you might start circling some of those that we just discussed and say, okay, can I now fill my weekly schedule with those classes? And if you were interested in taking 411 and 486, those are offered at the same time. That won't be possible. And that's what this particular weekly schedule for the fall is designed for. It's designed to maybe help you determine, oh, I actually wanted to take 450, 550, so that means I can't take 472, and I can't take, which we didn't talk about, 696B. But that's what this particular weekly schedule for the fall, and that goes all the way up to 630 in the fall semester. So you might look at this and say, oh, I want to take 441A. Again, that's one of the classes that's offered in the summer, but it's also offered again in the fall. And now you could take that class, you could take maybe the computer networking class, and now you're starting to see how your week is going to be blocked out. Maybe now you want to take the analog integrated systems class. Now you have this 1.5 hour block in the middle of the day pretty much filled up, and you could then take some other classes depending on what your interests are relative to technical elective coursework. Now, as you're planning your fall, you may also want to be thinking about your spring classes, because some of these spring classes actually might require already having completed some of the other classes. We don't have a lot of 2-semester sequences of classes, but there are some that you might benefit by taking the preliminary class. For example, 441A it will help you if you take that in front of or before 442, but right now 441A is not a requirement or prerequisite for 442, so you could step into 442 without having taken 441. Most of you will be able to take 330B as a technical elective unless you're in an older catalog in which it was a required class towards your degree program. But here, computational techniques allows you a way to understand, how do I numerically differentiate? How do I numerically integrate? How do I solve these differential equations? Oh, I want to do some optimization. They actually cover some optimization strategies and two-dimensional and three-dimensional graphing in ECE 330B. If you liked 369A, then you might want to take the next class, which is Computer Architecture 462. I'm not so sure that this class will be offered in the spring, but that's sort of Artificial Intelligence 2. You will be able to take the Artificial Intelligence 1 class, which is 479. How do you start thinking through, and you might just sort of envision artificial intelligence. What's that? Well, how do you play a game? How do you make a computer play a game? That's sort of how you create artificial intelligence with a computer. If you're interested in cybersecurity, then another class that you could consider taking is 471. This is using or introducing a lot of cryptography. That's 471A. And another class is many things are going to the cloud. What are the key concerns if your company is now using cloud services? How do you know what's being protected, what's secure? That's the kind of information that you will learn and skills you will develop in 524. Again, that's a graduate class, so you will have to have the appropriate GPA in order to step into that. In the microelectronics area and bio area, if you're a computer engineering option student, you can take 352 device electronics. How do you actually, or what's going on when you actually create a diode or a transistor? How does doping work? What does that really mean? How do you dope a system in order to make it perform the way that you want it to perform? Digital VLSI system design. Now you're looking at the digital aspect in very large scale integrated systems, and that's now sort of the digital version of what you might see in a 450, 550. Now you're looking at digital system design versus analog integrated circuits in 450, which was offered in the fall. If you want to know how do you create sensors or wearables, maybe a first step might be to think about taking this 417 class where you're now interested in measurement and data analysis in biomedical engineering systems. In the electromagnetics area, again, if you're a computer engineering track student or option student, you can take 381A as a technical elective. If you want to know a little bit about, not a little bit, if you want to better understand what's going on in solar energy systems and photovoltaic systems, 414A is a class to be taking. Optoelectronics, how do you design systems involving optical devices and electronics? That's 456. I'm not sure about the antenna theory and design, but that's a class that then would be following 381A. And how do you now create all of these antenna that you'll see in many different smart devices, and in particular your phone? How do they design those? How do you create those? And how do they actually work? That's 484. In the signals and systems area, if you're interested in machine learning and data analysis as it's applied to engineering systems, this is a graduate-only class, but that's 523. Digital image processing. Now this is a little different than digital image analysis. This is image processing. This is now, can you do transforms on images? Can you actually do a filter design? Can you do data compression? That's 533. And the first class beyond ECE 340A in terms of communications is 435A. That's digital communication systems. And the last class here on our list is digital control systems 442. This is tentative, obviously, because it's a year away, more than a year away, or not quite a year away, but you can now sit down and plan out your spring semester if you're really wanting to figure out what sequence of classes are going to be in your future. Here is the artificial intelligence class. You might say, okay, I want to take that together with, if you're in the computer engineering option, you can take 381A. You will want to make sure, though, that you are clear that 381A is a 4-unit class, and because of that, it has another meeting pattern to it. So you want to make sure that you do have your semester or your schedule planned accordingly. That's what I was hoping to cover in the technical elective material. Let's now talk about the accelerated masters, the admissions requirements, and one of the questions was, when do you consider the AMP? Really, you need to be considering it pretty much from day one, because you have to have a particular GPA in order to even be considered for the AMP program. You need a 3.3 cumulative undergraduate GPA. When you really get serious about this, when can you apply? You can actually apply halfway through your junior year, or when you've now completed a minimum of 75 undergraduate units. And a lot of you may be in your first semester, maybe you're in your second semester, sophomore year, when you accumulate 75 undergraduate credits, then you can apply to be in the accelerated master's program. And who is this for? This is really for anyone. If you're wanting to continue maybe a little bit more in depth with some of the courses that you've seen as an undergraduate student, the master's degree usually gives you a leg up, obviously, on your bachelor's degree counterparts. It will give you a quick salary boost, and the accelerated master's program, if you did the coursework only masters, a master's degree consists of 10 standard 3-unit classes. If you were in the accelerated master's program, you could take up to 4 of those as an undergraduate student. You would obviously have to take the graduate level courses, but now those 4 classes count towards 4 of your technical elective courses at the undergraduate level in the BS degree, and they also count if you now maintain your 3.3 cumulative undergrad GPA when you graduate. Now you can immediately step into the graduate program, and you only have 6 credits or 6 3-unit courses left to complete to finish up your graduate degree. And that means you would be taking 3 standard 3-unit classes in each of your next 2 semesters, so that in 5 years, if it took you 4 years to obtain a BS degree, now in 5 years you have a BS and an MS degree, all in electrical and computer engineering. So that is when you apply, is in your 75th, or when you have 75 or more units, you can actually start taking classes towards your AMP or in your AMP program once you are officially a senior, and you're officially a senior when you have 90 plus units. So once you have 90 plus units, that's when you can start taking these classes at the graduate level. So if it was a dual numbered class, you would want to take the 500 version. If it's a graduate only class, you can take that, and that would then be one of your up to 4 classes that you could take as an undergrad to satisfy both your undergraduate degree requirements and your graduate degree requirements. If it's a good fit or not, that's what you need to be thinking about now. But if you think that you want to maybe be in a more leadership role when you graduate, if you think you want to maybe be doing more design than simply building some systems that you sort of understand how to do based on your BS degree, if you want to go beyond that, then a master's degree could be what you want in your future. And that's when you might want to be thinking then about pursuing this AMP degree. That means you need to keep your GPA at a 3.3 or higher. You want to be thinking about applying after 75 units, and then you can start taking these after 90 units. I hope, and if you do have questions about the AMP, here is the email address that you can use to communicate with our graduate advisor, but you've probably already seen some email flyers containing the information about the AMP, but that now allows you to think about your technical electives and what courses you might take as a graduate student towards your master's degree. And I hope then that this particular session has been helpful or beneficial in trying to determine what do I want to take for my technical electives, and is AMP a valid option for me. Good luck.